Hello everyone, I am Vivek Raja, and today's session is gentle introduction to AWS SageMaker Autopilot. So a little about myself is I am from Madurai, Tamil Nadu, and I'm working as data scientist in Cortex PCI, which is a US-based startup, and I'm currently located in Delhi. And our startup is based on brain-computer interfaces and stuff. So I'm AWS Builder in Machine Learning Expert of 2021, and I'm 16 times multi-cloud certified in Azure, Alibaba Cloud, and Oracle, and I'm 20 times international national level hackathon. So I've been participating in hackathons from my college days, and currently I'm mentoring several hackathon teams, which went on to win several national hackathons as well. And also I'm currently as a technical judge in a couple of hackathons. And throughout my career, I have actually published 5+ research papers, and I've also filed for one patent in AI and IoT. And I'm a very active speaker in terms of machine learning and cloud, and mentor and a blogger and open source contributor. So today's talk will be about what is machine learning and a few concepts of machine learning, and we will actually see what is AutoML, so which is actually known as automated machine learning, and we will also try to understand what is the difference between AutoML and the conventional machine learning practices we do, and we will get started with AWS automated machine learning using the service SageMaker Autopilot, and we'll have a simple hands-on demo, and we will conclude this today's session. So what is the actual benefit of using machine learning is that there is a normal conventional practice where you use algorithms to do some predictions and stuff. But in machine learning, you use data to get the perfect algorithm depending on the data, and you predict based on your future data. So it actually helps us to uncover insights, improve the data integrity, and enhance the user experience and stuff. For example, if you log into AWS Amazon shopping website and you look for some items which you have to purchase, so automatically there is a recommendation feature which is going on, like if you people who have bought this product has bought this product as well. So this is one of an exemplary thing of machine learning which is running in the background, and also it helps us to anticipate custom behavior and lower the cost as well. So in machine learning, we can just fairly divide processes into four, which is like the first process is about data collection and pre-processing. So in which we actually try to identify the data source, we collect the data, we transform the data because the real world data is not actually very clean. So we have to clean the data by identifying the missing values, or we need to transform the data type of a particular column value. For example, if there is a column value of date of a particular date of birth of a particular person, rather than having that as a date of birth, we can convert it as an age, which gives much more value, as well as increases the understanding of the data as well. And next comes after all the data collection and pre-processing, we have to train the data. So the first method is to we need to split the data into training set and validation set, and we need to select the model. And this is one of the very hectic process of any machine learning engineer about what model he has to select, because when we take, there are several machine learning practices such as regression, classification stuff, and there are hundreds of machine learning models for each type of problems. So selecting a particular model and even tuning the particular machine learning model involves a lot of manual work, and it's a very hectic and tedious process. And once we actually finalize a particular model, okay, so this model gives me a good result. So what I have to do? So we have to validate whether the model is actually very good by validating on the test data, and we try to evaluate the results based on that. So this is kind of an iterative process which goes in a machine learning. So you train the model, you validate it, and you find whether the model is best or not. You go again, try some other model, and you do the stuff. So when you are actually convinced with some model which is giving you the best results, you go ahead and you deploy the model, and you get the results for by prediction and so on. So this is how a normal machine learning process looks like. And the reason why we actually understand this overview of the stages in machine learning is we are going to automate these processes using AutoML. So that's what we are going to do in this today's session. So what is AutoML, which is actually known as automated machine learning? So automated machine learning is a process where we automate the entire workflow of machine learning. So which involves data pre-processing, data collection, finalizing the model, and deploying it as well. So this is where actually the AutoML comes into picture. And why it is actually necessary for people to know about this AutoML feature. As you know, like not everyone is a data scientist by profession or machine learning engineer by passion or profession. So there are many researchers, application developers, or other people who does not have programming language but still have to perform machine learning in their aspects. So AutoML helps them in the feature. They don't really need to identify the mathematics or the other concepts behind it, but rather it gives you the best result along with the explanations that this is why this model is the best as compared to others. So this is one of the very amazing features in the recent terms of using AutoML. So an AutoML process actually looks like we give the input data and it does the feature selection. So feature selection is a way it tries to evaluate these features have more weightage in the prediction, and it tries to select those features. And once that is done, it goes to the second step, which is called model selection. So there are hundreds of models as we discussed, and it tries to evaluate the data on various models, and it selects the best model out of it. But even the best model can be improved by doing the hyperparameter tuning, and it does the hyperparameter tuning and gives the optimized model in the end. So this is how an AutoML process looks like. And now you may actually have a question. So what is the actual difference between AutoML and conventional machine learning practices? So if AutoML proves to be the better approach of doing it, why everyone is not doing it right now? So let's try to address this problem. So the benefits of having an AutoML is like we can have implement machine learning solution without having an extensive programming language or even having understanding of mathematics to implement machine learning as well. So this is one of the biggest benefit for people who are not into development or programming domain. And it saves the time and resources of implementation as well. For imagine if you have to manually do to evaluate 250 models, and you evaluate it and you find the best model out of it, then you have to improve your model by doing the hyperparameter tuning. But this involves a lot of time, and you have to invest a lot of compute resources for that. So that involves in machine learning normal conventional practices, but AutoML really takes care of using parallelizations and automated scripts to evaluate so many models in parallelly and give you the best results. So, and also AutoML always prefers to use the best practices in data science. For example, when it comes to data cleaning approaches, we tend to leave a couple of practices which needs to be involved. For example, imputing the missing value, or maybe trying to transform the particular column into some other columns, and so on. So this is actually taken care of by machine learning by doing the feature engineering processes, and you will get the results for that. So now that we understood like why AutoML has an edge over machine learning practices, but now arises a question again, why should I actually opt for automated machine learning processes? If automated machine learning processes proves to be the best one, why can't everyone use it? So now comes again this question where we'll try to evaluate when you actually have to use AutoML so that it proves to be beneficial for you or the organization you're working for. So if you're a non-programmer or a non-data scientist and you have to actually use machine learning in your application, then AutoML is one of the best way to do it, because you can try to address so many of machine learning problems within a simple number of clicks. And if you don't have a domain knowledge, for example, if you're working on a financial sector, but you don't have a knowledge on the finances you're going to work upon, so you tend to miss a lot of feature understandings or domain understanding in that aspects. But AutoML has a varied number of approaches which is used in feature selection and model selection, and thus this will be taken care of. And if your data is too complex to handle, then you tend to spend a lot of time in fine tuning it and cleaning the data. So AutoML data cleaning processes will help you in this stuff. And quick implementation. Yep, you will just get to see about how quick of implementing an AutoML feature in just a couple of minutes. So it hardly take an hour or more than that based on how do you want to run the experiment of machine learning as compared to hours and hours of manual labor work which you have to do for your conventional machine learning practices. So now that we actually understood like what is the processes which is involved in machine learning, and we also saw what is automated machine learning and why that proves to be the better approach in few scenarios as compared to normal conventional way of doing machine learning. And so this feature is available in AWS as AWS Autopilot. So we will see how that works. So in during training, your AWS SageMaker Autopilot creates a lot of pipelines in parallel to try different algorithms. So as I said, it has a pool of more than 100 to 200 plus models, and that can be actually trained and evaluated parallelly. And the best part of using AWS SageMaker Autopilot is that it actually explains you why your model is the best. There is an always convention that a machine learning process is more like a black box. You don't really know what is really going under the processes, under the hood. But when it comes to these kind of approaches, when you use automated machine learning, and if AWS SageMaker actually gives you an optimized model, it also explains the process, why it shows that model as to be the best, and what are the factors it took into consideration to analyze that is the best model as compared to others. So this gives a valid explanation of what all the processes has been carried out in data cleaning and feature selection, as well as model selection processes. And you can set the exit criteria of your experiment. For example, you might run a few less short on compute resources. So you can try to limit the number of models you want to evaluate. Or maybe like you can even try to define the exit criteria by number of minutes your experiment is going to run. For example, instead of running for 2 hours or maybe more than that, I can just limit my resources up to half an hour of usage, so that I can just find the best model among the half an hour of training of machine learning models which has been evaluated. So we will try to set up what are the steps we need to actually do this process. We need to go to AWS console, and hope so you have a free account to do this. And also please do check, have a note on the pricing section, because this module, if you're going to carry out in AWS, actually do involve some pricing. So make sure you have some credits in your account, and you can work on this. And you have to set up your input and output data source, and you have to set review conditions and exit criteria, and you have to run the autopilot. So once the autopilot is actually done, you will get the experiment results in the end. So what are the steps which is actually taken care of in the automated machine learning processes, which is autopilot? So there are 3 steps. So the first step is feature engineering. So in feature engineering, the autopilot experiments, it creates a training and validation data sets for your particular data. And it also generates a notebook called data exploration notebooks, which consists of all the information and statistics of the data. So for example, you need to analyze and have a statistical approach of the data to understand which features play a vital role in the prediction, or maybe which data needs to be eradicated so that it does not contribute much to the prediction as well. And with these notebooks and stuff, you can even understand how the data is pre-processed before sending that to the models. So this is one of the very good feature in Autopilot, which shows the transparency of machine learning processes, which is carried out by SageMaker Autopilot. And once your feature engineering process is done, now it's time for your model tuning. So AWS SageMaker has a plethora of so many models for the particular problem. For example, if you take a binary classification, there are more than 250 models which is eligible for the experiment, which needs to be trained on your data. So for each model which is supposed to be a candidate, there is an exclusive pipeline which is done, and it also runs a hyperparameter optimization job and training jobs for that, and ensures the best outcome of that particular model. So this is carried out between all the models, and you get the final results out of it. So now let's jump on to a hands-on session. account, please log into it, or if you don't have one, you can register for a free account, and make sure that this demo involves some pricing. So log into AWS SageMaker and you will see something portal like this. So the first step is to create a SageMaker Studio. So you haven't created a SageMaker Studio before, there'll be a get started solution for that, and with just a click, you'll be able to create a studio. So when your studio is created, you'll be having something like this. So click on Open Studio to open our SageMaker Studio. So the first step, what we are going to do here is we are going to create a notebook where we are going to run some an experiment where we are going to collect the data and put it in S3 bucket. So let's create I've created a Python notebook, and this is how it looks. So what we are going to do is we are going to work on sample data, which is the bank data set. So by running this command, we'll be able to get the data and we are going to unzip it. So let's try to read this data and see how that looks. So we have several columns here, so in which age, job, marital, and the final result is Y, which is a binary classification model. So which means we are going to predict whether this person has an eligibility to get a loan or not. So this depends on various features such as age, job, education, what's the contact, and so many other factors. So let's upload this in S3 bucket so that we'll be able to access it in our upcoming autopilot experiment. So by running this command, we'll be able to upload our data to S3 bucket. And then now it's time for us to create an autopilot experiment. So in the launcher section, you'll see something like this. So in this, create new autopilot experiment, and then let's give a new name for it. For example, reskill autopilot. And now we are going to enter the source data for our solution. So as we know, like this is our source data. So let's put that in our experiment. And we need to select our target column. So our from the S3 buckets data, we are able to locate the features which is involved in it. So these are the features, and as we know, the target feature which we are going to predict is Y, and Y represents whether the person is eligible for a bank loan or not. Now let's enter the location for output data. So it can be the same S3 bucket, or if you wish to select another bucket, that's totally fine. I'm just going to put my output in something in called the same S3 folder but /output. If you're not sure about the data set and what type of machine learning problem you're working with, you can just leave it as auto, and the SageMaker Autopilot will try to classify what type of problem it's going to we are going to work upon. But since we are very much familiar that this problem is a binary classification, let's go with it. And as of now, SageMaker Autopilot supports only 3 types of problems, which is regression, binary classification, and multi-class classification. So let's go with binary classification, and let's keep F1 as our primary objective. So do we want to run the whole experiment? Yes. So, and there is a provision for us to stop after creating a notebook of candidate definitions. We'll come back to the candidate definitions a little bit later, but let's try to run the whole experiment and get the whole grasp of it. And if you want to deploy your best model immediately, you can click on the auto deploy feature, or else as of now, let's turn it off, and it does not going to affect our autopilot experiment as well. And still, once a model is generated, the best model we have got, we are still able to deploy with one click, and we will see it in our experiment as well. So there are a few advanced settings which we can go about, which is about the IAM role and stuff, and what should be the maximum runtime hours for this particular experiment. So since this is not actually touched, the experiment will run for full by evaluating all the maximum candidates of 250, and we have the provision to change the number of candidates as well. So let's keep these details in settings as default, and let's go ahead and create our experiment. By creating this experiment, actually we'll be launching this experiment, and this goes for creating the data featuring data exploration, and then it statistically analyzes the data, and then it does the feature engineering. Then the model selection takes place with the hyperparameter tuning. Then it delivers the best model. So for the demo purposes, I have already run the SageMaker Autopilot experiment, and let's see how the results have come back. So we have got the autopilot experiment here, and it has. I have stopped this experiment after a while, just for the demo purposes, but we can run till the end of the experiment. So these are the models the SageMaker has evaluated, and it suggests that this model is the best one. So the reason why it has suggested is like because it has got an objective of F1 binary score of 0.597 as compared to other models. So let's see about the job profile of this particular experiment. So the job profile is where it contains all the necessary information about a particular experiment, which has got about the input configuration, output configuration, what are the attributes which has been dealt so far, and what is the job configuration. So since we have given a criteria of evaluating maximum of 250 candidates, it went with that. And what was the best candidate, and what was the summary of that, and all the inference containers which is available for it. And since we talked about something called a candidate generation notebook and a data exploration notebook a little earlier before, so this explains the transparency of how an autopilot experiment arrives at deriving the best model for our particular data. So a data exploration notebook is about saying how the model has understood the data. So it shows an example of how the data has been sampled, what was the analysis made on the columns, and it also understands if there is any missing values that needs to be filled with respect to the categorical and numerical values. And this is how it has understood the particular data and all the statistics associated with it. And the candidate generation notebook actually deals about what are the candidates it can actually evaluate for this particular model, and how to run the experiment loop to evaluate all the models. So as we seen in the earlier settings, we can stop by generating the generation notebook, and it's our users wish to run the candidate notebook or not. So we can just take a look at how it looks, and these are all the contents of the, it downloads the generated candidates, and it generates the pipelines and so on. So now coming to how to deploy a model, you have to just right click it and deploy the best model as available. But you can't deploy the models even if it's not the best model. So it's up to you to decide on which model you have to deploy. But when it comes to auto deploy, automatically deploys the best model which is available as of now. And also we can click the model details to see how this model has performed and what are the values it has got associated with it. So these are the final values of the AUC, validation and training accuracy and everything. And these are the other hyperparameters which has been set, and it is found to be the best for this particular model. And also it reads about how this model has arrived at the best prediction values and so on. So this model is nothing but an XGBoost model, and for the type of binary classification. So these are the artifacts which has taken into consideration. You can even look at the feature engineering code which is available, and the other necessary details. So at the end of the experiment, we are able to deploy with just one click of deployment, and you can create a real-end deployment pipeline with just one deploy model with giving the necessary settings. So you have to give the endpoint name and the instance where you're going to deploy and the necessary details for it. Once that is done, your model is ready to serve a real-time API, can be consumed as a real-time API, and that's how a machine learning model, an autopilot experiment works in creating the best model by giving the data, working on the data and transforming it, as well as creating the best model and able to deploy it with just number of clicks. Now let's get back to our presentation slides. So as we have seen in today's session, we learned about what is machine learning and what are the steps which has been taken care of in machine learning. We also learned about what are the features of an automated machine learning looks like. We compared the automated machine learning with conventional ML practices. Then we saw the steps which is involved in automated machine learning. We also saw about Amazon SageMaker Autopilot and what are the features it offers to us in this particular scenario. Then we went on to create an autopilot experiment, and we evaluated on a bank data set, and we got the best model, and we also see how to deploy it as well. To know more about this, you can even refer the links where you can learn about my machine learning related. If you're new to machine learning, you can just hop into my blog, which I wrote about what is machine learning and stuff. If you want to learn more about automated machine learning, you can refer the official AWS documentation given here.